Imagine a world where every coding mistake could cost you hours of work, where team collaboration feels like navigating a minefield, and where tracking changes is like trying to catch smoke with your bare hands. Now, what if I told you there's a superpower that can transform this chaotic coding nightmare into a smooth, collaborative journey? Welcome to the world of source control management with Git, where developers become code wizards, turning version control from a headache into your most powerful development ally. Welcome to another lecture from the Programming Professor. By the end of this video, you will understand the fundamentals of source control, key Git concepts, best practices, and workflows like Gitflow. Let's get right into how Git can make collaboration smoother and more efficient for software teams. Every developer faces common development challenges, and source control management addresses these challenges. As an individual, you may have faced broken code, lost files, or confusion over file structures. As a team, challenges include sharing changes, handling concurrent edits, and tracking who changed what. SCM provides solutions to these problems by introducing structure, accountability, and a clear process for collaboration. Source control management, or version control, tracks changes to files. SCM also maintains a complete history of changes and safeguards against data loss, enables collaboration, simplifies conflict resolution, and provides rollback capabilities. Think of it as an advanced undo system for individuals and teams, ensuring stability throughout development. Version control has evolved significantly over time. We started with CVS in 1990. Then in 2000 came SVN. Git emerged in 2005, along with Mercurial. Over the years, we have moved from centralized to distributed version control. Early systems like Concurrent Version System, CVS, and Subversion, SVN, were centralized, relying on a single repository and network connectivity. Git and Mercurial introduced distributed version control, allowing developers to work offline with local repositories. Distributed systems offer greater flexibility, redundancy, and modern workflows, making them the standard in software development. Git operates through 4 key components. The working directory is where you edit files. The staging area prepares files for commits. The local repository stores your personal version history. The remote repository is shared with your team and hosted on platforms like GitHub. Together, these components form the foundation of Git's functionality. The working directory is where you create, modify, and organize files. Files here can be in 4 states: tracked, untracked, modified, or unmodified. Use git status to view these states and git diff to see unstaged changes. These commands ensure you are always aware of the state of your project. The staging area is your review zone. It allows you to prepare files for commits, group related changes, and verify them before committing. Use git add to stage files, git reset to remove files from staging, and git diff stage to review staged changes. This process ensures you only commit what's intended. The local repository stores your project's history, including all branches and commits. It allows you to work offline, experiment, and roll back changes if needed. Key commands include git log for viewing history, git branch for managing branches, and git checkout for switching between them. The local repository gives you full control over your project. To interact with a remote repository, you use 3 main operations. Git push uploads commits from your local repository to the remote one. Git pull downloads and merges changes from the remote repository. Git fetch downloads changes without affecting your working directory. These commands keep your local and remote repositories synchronized. Following Git best practices ensures smooth collaboration. Commit often with descriptive messages, and make sure each commit represents one logical change. Use feature branches to isolate changes, pull updates before starting work, and push your completed features promptly. It is best to require code review before merging the feature branches into the main branch. Initiate these code reviews via pull requests. Following these habits minimize conflicts and improve team efficiency. Be sure to regularly review the staging area with git status and git diff. Commit messages are crucial for understanding your project's history. A good message includes a short summary, an optional detailed explanation, and references to issue numbers when applicable. Use the imperative mood to describe what the commit does, focusing on what changed and why. This clarity benefits your entire team. In this example, we see modeling of all these commit message qualities. A simple Git workflow involves checking file statuses with git status, pulling the latest changes, staging files with git add, committing them with meaningful messages, and pushing updates to the remote repository. This process keeps your work organized and synchronized across both the local and remote repositories. For larger team projects, the Gitflow Workflow is an ideal branching strategy. Created by Vincent Driessen, it defines roles for branches like main, develop, and feature branches. Main contains production code and only receives merges from develop. Develop integrates features, and feature branches isolate individual changes. This structure ensures an organized release process. Let's set up an example scenario. Developer A and Developer B work on the same file. Developer A will add a feature A method, while Developer B will add a feature B method. They use feature branches to isolate their work and start by pulling the latest develop branch. This setup prevents conflicts and streamlines collaboration. Both developers create feature branches using Git commands. Developer A switches to the develop branch, creates a branch named feature branch 1, and switches to it. Similarly, Developer B creates a branch named feature branch 2. Working in isolation allows each developer to focus on their feature without interfering with the other's progress. Developer A implements the feature A method in their branch. This method prints feature A implemented. Developer B implements the feature B method, which prints feature B implemented. By isolating these changes in separate branches, they avoid conflicts and ensure clarity when merging later. Once changes are made, both developers stage and commit them. They use git add to stage the modified file and git commit to save the changes locally. Each commit includes a descriptive message explaining what was added or changed. This step preserves their progress and prepares their branches for sharing. Both developers then push their branches to the remote repository using git push. Developer A uploads feature branch 1, and Developer B uploads feature branch 2. These branches are now available for review and integration, ensuring a clear process for incorporating their work into the main project. Developers submit pull requests to merge their branches into develop. A pull request is a formal way to propose code changes and invite reviews. Developer A creates a pull request for feature branch 1, while Developer B does the same for feature branch 2. During this process, code reviews ensure the changes are high quality and adhere to project standards. Reviewers check for issues, provide feedback, and approve the changes if everything looks good. Once approved, the branches are merged, integrating the features into the develop branch. Following pull request best practices ensures this process is efficient and constructive. Before creating a pull request, test your changes thoroughly to ensure they work as expected. Update your branch from develop to avoid introducing merge conflicts. Review your own code to catch obvious errors. During the review, respond to feedback promptly. Keep discussions professional and document significant changes. After merging, delete your feature branch, verify the changes in develop, and update your local repository. Once the pull request is approved, the feature branches are merged into the develop branch. This step consolidates the changes, ensuring the project is up to date. Developer A merges feature branch 1 into develop using the git merge command. Developer B follows the same process for feature branch 2. Sometimes, merge conflicts occur during this process. Merge conflicts happen when changes in different branches overlap or affect the same lines of code. To resolve a merge conflict, use the git merge branch name command and check for conflicts. Open the file in a text editor, manually resolve the conflicting sections, and mark the conflict as resolved with git add file name. Complete the merge by committing the resolved changes with git commit. This step emphasizes the importance of communication and frequent pulls to minimize conflicts. After merging, the develop branch now includes both feature A and feature B methods, demonstrating successful collaboration. The project is now updated with the latest features, ready for further testing or development. This workflow demonstrates how Gitflow ensures a clean and efficient process for integrating changes. Best practices for parallel development ensure teams work efficiently without stepping on each other's toes. Communication is key. Inform your team about your feature branches, discuss potential code conflicts, and hold regular sync meetings to align efforts. Clean code practices are equally important. Make small, focused commits with descriptive messages, and regularly rebase your branch with develop to keep your work up to date. The code review process is essential for catching errors and maintaining quality. Provide constructive feedback, complete reviews quickly, and follow up on suggested changes. In summary, source control management is essential for modern software development. Git provides powerful tools for tracking changes, enabling collaboration, and managing conflicts. Best practices and workflows like Gitflow streamline teamwork, ensure quality, and prepare teams for successful project delivery. By following these practices and workflows, Git and Gitflow make parallel development and collaboration manageable. Each team member can confidently contribute to the codebase, knowing their work is organized, traceable, and conflict-free. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more lessons on computer programming and technology. See you next time.